Good morning, students. Am I audible? Okay, so I think in the last class we have discussed types of jump, right? Types of jump is over, I think. Okay, so types of jump is over. Then I think we have discussed about this thing also. Losses of energy, is it over? Losses of energy, this is types of jump. Then I think length of the jump, I think we have discussed. We have two equation, this two. So when your FR1 is greater than 5, your length of jump will be 6.1 times of hj. That is the height of the jump. Okay, and height of the jump is nothing but y2 minus y1. Okay, y2 minus y1. If it is less than 5, then we will go for 6.9 hj. Okay, that is 6.9 times of height of the jump. Okay, so next, loss of energy, I think we have already discussed now. Loss of energy, yeah. This is the equation for loss of energy. I think we have already derived this expression, right? This is the loss of energy equation. That is nothing but y2 minus y1 whole cube divided by 4 y1 y2. Okay. Then we have efficiency of the jump. Efficiency is nothing but E2 divided by E1. That is your efficiency of the jump. E2 divided by E1. Okay. So now we will move on to the numericals. So you write down this example 7.1. Okay. You write down this question. Okay. 7.1. So we have to prove for a horizontal rectangular channel to create a hydraulic jump. This satisfies, that is yc cube is equal to y1 y2 multiplied by y1 plus y2 divided by 2. Okay. Here y1 is nothing but depth of flow before the jump. Y2 is depth of flow after the jump, and yc we all know it's a critical depth. Over. So now to solve this kind of numericals, we have to use this equation. Okay. So now what is this equation? If you can, for this equation, you can go back. Just wait. Okay. So you can go back and you can see here for the derivation of our sequent depth, that is your y1 and y2, we have already derived this expression. Okay. You can already we have derived this expression. So we are using this expression. Okay. For again in loss of energy also in derivation, if you can see, we have used this expression. Okay. And for solving that numerical also, we will use this expression. So the derivation is already here. We have already derived this expression. Okay. So we are going to directly use this expression in this numerical to show that yc cube is equal to y1 y2 y1 plus y2 divided by 2. Okay. So we use this expression. Then we bring this term in left hand side. Okay. And other term in right hand side. Then we all know that for critical depth equation for rectangle channel is small q square divided by g to the power 1 by 3. Okay. Substituting this term here in this expression, q square z is there. So in place of this, we can write yc cube, because if you see in the question, we need yc cube. Apart from y1 and y2, see in right hand side, we have y1 and y2. Okay. So apart from y1 and y2, we should have yc term also in this particular expression, because we need to derive, or we have to show that our critical depth cube is nothing but y1 and y2, y1 plus y2 divided by 2. Okay. So for this thing, we should have yc in that particular equation. Okay. So to bring that yc, we know yc for a rectangular channel is q square by z to the power 1 by 3, or you can write this, or you can write yc cube is equal to q square by g. Okay. Here in terms of q square by g, we will directly substitute yc cube here in this expression. And you can see that we have twice q square g is there, we have substitute yc cube. Okay, is equal to, then we have multiplied. Okay, we have this thing here. You can see in this equation, this part, if you want to see this part, we have y1 and y2. So here also we have y1 and y2, so we have taken y1 and y2 common. Okay. So the left out is here y1 square is there, so we will be having y1 plus you have y2 square, so you'll be having y2. Okay. Then this 2, if you bring in here in right hand side, it will be square divided by 2. Okay, it's very simple. only you have to use this expression, and you bring yc in place of q square by g. Q square by g is nothing but yc whole cube. Okay, we move on to next numerical. Okay. Okay, so we will do the next numerical, that is our 7.2. Okay, so you kindly write down the numericals. Okay, here it includes everything. Okay, so if we solve this numerical, it will be little bit clear to you. Okay, we are going to find out the y1 and y2 value. I think y1 is already given. We need to find out y2 value, height of the jump, length of the jump, loss of energy, efficiency of the jump, types of jump also, and then we are at the end we are going to find out the ratio. Okay, so first you kindly write down the question. over. Hmm.